Hi, welcome to our presentation. In this presentation, I'm going to share with you our experience in a flipped classroom study back in summer of 2014. The flipped classroom, as you may have heard of it, is a pedagogy in which direct instruction in class are flipped with practices and revisions or other learning activities at home. So the students watch video lectures or complete other pre-class preparations before the taught sessions. So when they come to school, they have more time for active learning activities. Our institution specializes in pre-service teacher education in primary mathematics. The course concerned is titled Mathematics Exploration with Technology, which was conducted in the summer semester of 2014. There were 3 hours of content for every evening of Thursdays and Fridays for a total of 5 weeks. So the total number of contact hours was 30. The lessons were held in a computer lab in which the students had access to Windows desktop computers with high-speed internet connection. The course covers the use of Microsoft Excel VBA and a mathematics simulation tool called GeoGebra in teaching primary mathematics. So the course learning outcomes are mostly practically oriented. I'll come back to these learning outcomes a little bit later. So in this presentation, we first look at the theoretical considerations in designing the teaching methods in our flipped classroom. Then we share some of the practical experience in the implementation. And finally, we look at some research data collected during the study, discuss their meanings, and give some suggestions on how we can improve the implementation. Now, let's begin with the theoretical considerations. To design the teaching methods, we need to use the concept of constructive alignment. The idea of constructive alignment is very simple. So here we have the course intent learning outcomes, or CILO, silos, in the middle, which are written explicitly in the course syllabus. These learning outcomes represent what we want the students to achieve at the end of this course, so it is practically a target-oriented approach, or an outcomes-based approach to be specific. Now, constructive alignment means that we need to design the teaching method and the assessment around these intent learning outcomes to make sure that these learning outcomes can be achieved at least at the design level. How do we do this? To do this, we classify the learning outcomes according to the levels of cognitive processes involved in the learning. This can be done using the Bloom's taxonomy, which in one of its versions defines the cognitive levels as shown in this figure. You see at the bottom we have the remembering of factual information. Above this level is understanding of basic concepts. And these two levels are considered lower order cognitive processes because, say for example, in order for students to remember some factual information without any further elaboration, we simply need to tell them directly. In this case, the traditional didactic instruction may already do a very good job. The same is true for understanding basic concepts, which often involves linking simple facts together, again, without further elaboration. But as we move outward, the cognitive processes involve more and more advanced skills. Here, the third level is about applying knowledge and skills to solve some practical problems, which happens to link to one of our learning outcomes. Here you can see it says to use technology to enhance learning. Up one more level is analyze, and we go up again, we have evaluate, which is linked to another learning outcome, which says evaluate the impact of technology on the teaching and learning of mathematics. And finally, at the top level, we have create, and we also have a corresponding learning outcome, which is to adapt mathematical software packages appropriately in their classroom and in carrying out mathematics explorations. Now, some researchers in the field of active learning suggest that these higher order learning outcomes may not be achieved effectively using the traditional approach, but rather they suggest adding more interactivity to let the students actually work together on problem-based learning activities, which will be more effective according to their research. This theory is supported by constructivism and some modern neuroscience studies, but I'm not going to go into the details here. So now it seems that there are different learning methods suitable for different learning outcomes. For lower level learning outcomes, didactic instructions may work very well, but for higher level learning outcomes, active learning may be a better answer. Yet, I want to emphasize that even for these higher level learning outcomes, the students still need to satisfy some basic learning outcomes first as foundation stone before they proceed to the active learning activities. So it means that usually we need to do both. First, using didactic instructions for background knowledge, and then engage the students in active learning activities. But now here is a problem. How can we pack all these together in the limited class contact hours? The answer, as some of you may already know, is that didactic instructions need not be conducted in the presence of a teacher nowadays, as teachers can prepare video lectures and upload them online so that students can watch these video lectures at home before they come to the face-to-face teaching session for active learning activities. And this can be done even without modern technology if teachers use pre-reading rather than video lectures as didactic instructions. So although the flipped classroom is usually presented as a technologically enriched pedagogy, it does not need to be the case. You can do flipped classroom without any modern technology at all. You can do it even if you happen to, say, travel back in time to 100 or 200 years ago. You can still do flipped classroom without the computers, without the internet. So here is a decision tree to help you design what teaching method to use. We start with the learning outcomes at the top. We ask if this learning outcome can be effectively achieved without face-to-face interaction with the teacher or peer students. If the answer is yes, then we ask the students to do pre-tasks such as doing a pre-reading or watching video lectures before the lessons. Otherwise, we leave that to the teaching sessions, in which case we ask a second question. Does the learning outcome involve higher levels of cognitive skills? If the answer is yes, we design an active learning activity to develop that learning outcome. But there are also situations when didactic lectures should be delivered in class. For example, for some difficult to understand concepts, The teachers may want to teach this in class so that they can get instant feedback about how well the students understand the concepts or answer questions in real time. Or sometimes they simply want to wrap up the previous activities or give some feedbacks to the students. We call these mini lectures because they don't usually take up a large chunk of time as in the traditional classroom, but rather only last for 10 or 20 minutes. So these are the theoretical considerations we need to take care of in the planning stage of the course preparation.